Okay, question 18. Find the shortest distance between the curve y equals x squared plus 4 and the line y equals 2x minus 2. Good. Okay, so let's have a look. So let's draw a picture to see what's happening first. So x squared plus 4. So I'm assuming that they don't touch, of course, yeah, because if not, the shortest distance must be 0, and 0 is none of the options. So x squared plus 4, something like this, yeah. And 2x minus 2, okay, so y-intercept minus 2, gradient of 2, so I'm assuming, something like this. Yeah? That's how the picture looks like. So the shortest distance should be somewhere, somewhere here, maybe. Somewhere here. Good. Okay. So if we know those 2 points, then we just find the distance between them, then we're done, right? But then the issue is, well, where on earth are those 2 points, right? Okay, so first of all, we've got to think, this shortest distance, happens when? So it happens when the point here has the same gradient as the line, right? So the gradient of the line is 2. Yeah, the gradient of the line is 2. So therefore, you've got to figure out on which point on the curve is the gradient 2, right? Okay, so gradient, so differentiate, right? So y prime equals 2x, then you ask yourself, 2 equals 2x. Alright, so then x must be 1. So this point must have x coordinate 1. Yeah, must have x coordinate 1. Good. And then, so if x is 1, then y is 5. Yeah. So you might wonder, okay, how come the gradient must be the same? The easy way to think about this is that, okay, imagine you move your line, yeah, and then you try to stick the line closer and closer to the curve without rotating it, of course. Yeah. Then eventually, the first point you touch will be a tangent point, right? The first point you touch will be a tangent point. Then you know that, well, the gradient of the tangent is the same as the gradient at that point, right? So that's why the point there is a gradient 2 as well. Yeah? Okay, so if that's 1, 5, well, how does that help with finding this guy? How does that help? Well, the shortest distance must be perpendicular, right, to the line, right? Because if you go slightly tilted, then you sort of get a hypotenuse, right? So it's longer than the perpendicular distance, right? Okay, so then I know if I think about this line, sort of the normal line. Let's not use red. This guy here, the normal line, right? The gradient is -1/2, and you know that it passes through 1, 5, right? So you can figure out the equation of this. You can figure out the c. When x is 1, y is 5. So c is 5.5, 11/2. Sweet. Then now you just need to figure out the intersection of the 2 curves, right? So therefore, we have 2x minus 2 is the same as -1/2 x plus 11/2. Okay, annoying algebra, of course. 4x minus 4 equals -x plus 11. And then what do we have? 5x equals 15, so x must be 3. Yeah? So if the x is 3, then we know the y is 4, yeah? Because 2 times 3 minus 2, that's 4. Good. So now what's left is to figure out the distance between these 2 points, yeah? And of course, our friend Pythagoras helps us do that. So the difference in x is 2, the difference in y is 1, so 2 squared plus 1 squared equals square root of 5. Yeah? So the shortest distance between them must be square root of 5. There you are.